Hey guys, Corey back here with Iconic Metalworks, and I know it's been a while. I've been busy. I've been dealing with some health issues, and in my downtime, I've been building this new machine that I think a lot of you guys would appreciate. I'm building my own version of a Pullmax, and I'm going to take some of it apart so you guys can kind of see some of it. But I don't have the motor yet. I'm still in the design stages. I've got some of it. A lot of it's machined. But this here, it's just like a normal Pullmax. As you can see, this here rides on a cam, which I have the bearing. If you can see inside there, I have everything inside that's built except the big flywheel is what I'm going to call it. This actually lowers down, so there's 3 settings. At this particular setting, the travel of this is only around 100 thousandths. This one here is around 120 to probably 150, and then this one here is up to 200. And I'll know the exact ones when I get the flywheel mounted to the connecting rod. So what I'm going to do is I'm going to start taking some of this apart so you guys can kind of see what I'm kind of designing. Everything that I've built on this is based off of a Whitney Jensen. This was a 5-ton kick press. It's all 5/8 plate. My head unit I designed and built myself. It's bolted on. This piece down here that I'm designing as well will be bolted on, so if later on down the road I ever wanted a deeper throat, I could just take this off, re-engineer a new throat, and I have a big machine. This particular machine is a 2-foot throat, which I think is adequate for what I do with sheet metal shaping. Some of these collets that I have, these are square collets. These are actually made out of Australia, and these are just your standard CNC ER32 collet nuts. But I have to take this off to pull all this stuff out. So as you guys can see, I'll get this out, and then I'll pull the piston out with all the linkage. Because I already have my bushings pressed in. So this is the mechanism. This will be where the bearing is on the flywheel, which runs on that eccentric cam. And all you're doing, it's going to be hard. It's basically this just pushes. Everything is at 0, and then the cam will pull it apart, pull it away from it, which drives this up, and then it pushes it back to dead center. These, I've made every piece in here. Welded it, machined it, bored it, threaded it, everything. So this is the inside guts. That particular one where the bushing is, it rides on this cam. This cam is offset, so you can get different. It basically starts out up top, as you can see, and then what happens is you start to rotate it down. Obviously this is going to be a mirror image. It starts swinging this particular center. It swings it on a pendulum, so as it pulls further away, that's where it's over here. You're going to get your maximum stroke. I'm 400 thousandths offset on my cam, so as you pull it over here, you're basically lengthening that to pull. So it's going to be, say, roughly a little over a 1/2 inch throw, and then as you start coming back and you start bringing it back in, which is down here, which is pretty close to 0. It's dead nut, so you're at 400, and then as you bring, obviously, it closer, it's going to move the center point of that cradle over here. So it's going to take your 400 and it's going to subtract, so you're going to be beaten at, like I said, your 100 thousandths. It's going to move it closer, so out of your 400, that thing's only moving about 100 thousandths to move. And obviously there's some other geometry involved as well. This thing does have seals inside. I machined this, and I decided to do a double seal, which I don't know if it's necessary, but I just like to do some overkill. And I'll show you. So there's a seal that's machined in this square bore, and then I got the wild hair to basically machine this cap to kind of keep in the seal that's in there. This cap is going to basically press up against the existing seal. So I was like, well, what if I put another seal right on the back side? So I machined this down. So it's going to be two seals pushing on each other that lock in that can't come out. This is going to be a solid wet bath. You're going to have oil flying in it. I'll come back on this side and I can show you. So this is the offset cam. I welded this on. I didn't over machine. I just I overthought. But this is to space this to get it perfectly in line with this once it's up and running on the bearing. And like I said, I've got a drain plug down here to empty it. I will pull this out. So this is my shaft. It's a 1-inch shaft to be driven with a 5/8 shaft motor, which will be roughly 1725 RPM. I am going to put it on a VFD drive so I can control the speed as well. Inside this back hub, which I'll grab the camera and show you, there's two bearings. I made a split housing because the way that the bearings go in, they're pressed in, but if I ever had to service them, I can on the back side. Like I said, I'm in the process of this. If you guys, I know Pullmaxes are kind of getting out there. They have numerous styles that people are trying to come out with. I'm just trying to replicate what an original, but just make it to my own deal to accommodate what I do. If you guys like this video, like and subscribe down in the lower corner, and I will be posting more once I get the material and I get some of this stuff machined to build the lower cradle and get everything in line and get more gap. There is a seal also, since it's a wet bath. So this will get machined where my black lines are, and that's what's going to lock in that spring-loaded handle, which I designed. But as you can see, this has a counterbore in it as well. So there will be a seal that goes in here. This comes in and basically keeps the seal from flying out and keep oil from dripping out on the machine. This particular one right here is going to be a sight glass, so I know the height of the oil. And then my cap, I did it out of 3/8 plate, and these are just an oil drain plug. So one with a copper washer. The front base and the back base is 1/4 inch, and then this is 1/8 inch plate that's been bent to fit the whole machine. So, like I said, if you guys like this video and you guys want to see more of this particular build, please let me know. I'm not selling blueprints to this like I do my bead roller, but I encourage you guys to, you know, think outside the box, like I've always said, and build some of your tooling that accommodates for what you need.